In section 6.4, we're going to factor some special forms. To begin with, we're going to look at the product right here of 2x plus 5 times 2x minus 5. We know that 2x times 2x is 4x squared. 2x times negative 5 is minus 10x. 5 times 2x is positive 10x. And 5 times negative 5 is negative 25. So we've seen before that in a product of conjugates, two of the same thing with an opposite sign in the middle, that our middle term will cancel. Positive 10x plus negative 10x adds to 0, giving us 4x squared minus 25 for our simplified answer. What we're going to look at in this section is the reverse, taking our answer and factoring. So when I see something like 4x squared minus 25, I know that's going to factor back into the 2x plus 5 and the 2x minus 5. Now let's take a second to figure out how we got there. Okay, how I could get here without knowing that I just did this problem, that's what I would have had. So thinking about those numbers and doing the grouping or the trial and error method, I would be trying to get two numbers that multiply to 4 and two numbers that multiply to 25 and added to 0. In the middle of this right here would be a plus 0x term. Okay, so if I look at over to the side right here, if I look at, let's say, the product of 4 and 25 is negative 100, and I could add to 0 with a 10 and a negative 10. So if I write this down and group it, 4x squared plus 10x minus 10x, that's my 0, minus 25. Let's factor. So factor by grouping, 4 and 10 have 2 in common and an x, so it leaves me with 2x plus 5. First term's negative, so I've got negative, those have a 5 in common. If I take that out, I've got 2x, negative 25 divided by negative 5 is positive 5. So 2x plus 5 is in common, and what's left is 2x minus 5. Okay, so we've just done the same problem using the grouping method. And we can see that it also works by trial and error. By trial and error, we're going to be looking at this combination of 2 times negative 5 and 2 times positive 5. We want the exact same things here and here, one positive and one negative. Okay. So, the difference of two squares will always factor. Difference of two squares, meaning the subtraction of two perfect squares, like the 4x squared and the 25, will always factor into binomial conjugates. They need to be binomial conjugates to get this to be the exact same thing with an opposite sign to add to that 0x in the middle. Or squares right here, this needs to be a perfect square for this to subtract to 0. It needs to be the same number twice to subtract to 0. Okay, so the difference of two squares will always factor into binomial conjugates, so a plus b and a minus b. Alright, so let's look at a couple of examples here. X squared minus 9 is going to have to factor into x. Okay, 9 is, I know it's 3 squared, so this will be x plus 3 and x minus 3. If we check it, x times x is x squared. This path right here gives us a minus 3x. That one gives us plus 3x to add to 0, and then our negative 9. Okay, so that checks out. Oops, that was a humongous eraser. So x plus 3 and x minus 3 is our solution. Okay, that's a difference of two perfect squares. Now, so is this. 4 is 2 squared. 81 is 9 squared. It's a difference of two squares. So it should factor into 2r plus 9 and 2r minus 9. 36k squared is a perfect square. 49 is a perfect square. So this should factor into the perfect square. For 36, it would be 6 squared. It's going to be 6k minus 7. And 6k plus 7. Notice that I wrote the subtraction first this time. It doesn't matter which one's written first, I just need to have both of them down there. Okay, one is positive, the other is negative, and they're perfect opposites of each other. They're conjugates. Is 49 a perfect square? Yes, it's 7 squared. 64 is 8 squared. This is, again, perfect squares. So it's a difference of two perfect squares. It will factor into 7 squared. 7 squared is 49, so it'll factor into 7 x plus 8 y, and the opposite, 7x minus 8y. It's binomial conjugates. Same thing, opposite sign. Alright, 25, that's 5 squared, so this will be 5x. 16 is 4 squared, so we'll do 5x plus 4, and 5x minus 4. And the last one here, this is n squared plus 9. Now, think for a second. Does n plus 3, n minus 3 work? So this would give us n squared. That would give us minus 3n plus 3n to give us no n in the middle, which is perfect. But that last number would be minus 9, not positive 9. So this does not work. Okay, the binomial conjugates will always give us a negative, a difference of squares. What do I do about a sum? Okay, well, if it's a sum, could it be n plus 3, n plus 3? I mean, you need positives to multiply to a positive, or the same sign. But that would give us n squared plus 3n plus 3n plus 9, or 6n in the middle. So that doesn't work. Okay. What other ways can I make 9? 3 and 3, 9 and 1, but that'll add to 10, or subtract to 8. Doesn't work. This one's prime. Okay. The difference of squares will factor. The sum of squares is always prime. I'm going to write that down and then explain it again. The sum of squares is always prime. And it's prime because you're trying to add to 0. The only way to add to 0 is with a positive and a negative of the same thing. But a positive times a negative will always be a negative, never a positive, never a sum. So if you have two numbers that are an opposite sign adding to 0, n, or whatever in the middle, if they're opposite sign, they will multiply to a negative number. They can never make that positive number right there. So the sum of squares is always prime. Right? So let's factor some more of these right here. 49, that's a perfect square. X squared, that's a perfect square. Is x to the 4th a perfect square? Yes, it is. X to the 4th is x squared squared, right? So this will become 7x squared minus 4, and 7x squared plus 4. Okay. X cubed. That's not a perfect square. Neither is 2, or 72 for that matter. But there's a GCF, something I can take out first. Divide everything by 2x. It leaves me with x squared minus 36. Now those are both perfect squares, so I can continue factoring this, and I'm going to get x squared minus 36 will be x plus 6 and x minus 6. Okay. X squared minus 16, that one's going to work like our x, I'm sorry, that was x to the 4th. It's going to work like our x squared squared up here. So it's going to be x squared plus 4 and x squared minus 4. X squared times x squared is x to the 4th. Minus 4 and plus 4 are the same thing. We'll add to 0 and our negative 16. Now we've got to keep going. Notice I can't factor the sum of squares. This is a difference of squares again, so that one's going to factor even more. So x squared plus 4. And 4 is 2 squared, so this will turn into x plus 2 and x minus 2. That'll be my final answer. Alright, what about x to the 6th? In the same logic that x squared squared was x to the 4th, okay, what would I have to square to get x to the 6th? It would have to be x to the 3rd, right? Because those powers multiply. So this will factor into x to the third plus 3 and x to the third minus 3. Okay. And this last section right here is really just mentioning that when you have something that has two of the same thing, for example, you're just going to write it as that thing squared. And we'll just see how a couple of these work out. This is a coefficient 1 problem, so I know I can start it off with x in both parentheses. I need it to add to 1, multiply to 1, and add to 2. The only way to multiply to 1 is 1 and 1, but 1 plus 1 is 2, so that works. And we're just saying here that, again, those are the same thing, so I would prefer to write that as x plus 1 squared rather than having to write the x plus 1 twice. Okay, so we'll try the same thing over here. Okay, 25 is 5 and 5. So I'm using trial and error here. 1 is 1 and 1. Okay, to make a positive 1 but a negative 10, those better both be negative. And let's check it out. We've got negative 5 and negative 5 for a negative 10. That's what I want, so that works. It's two of the same, so instead of writing it like this, I'm going to just write 5y minus 1 squared. And lastly, right here, 16, I could do this as 1 and 16, 2 and 8, or 4 and 4. Let me try the 4 first. 25 could be 1 and 25 or 5 and 5. Let's try the 5 first. It's positive, so those need to be two negatives. We want to add to a negative 40. And that's going to add to, let's see, negative 20 minus 20. So yes, that adds to negative 40. Perfect. The only thing I forgot to add in there was the y, because it wasn't just a 25, it was a 25y squared. So let me go ahead and stick my y, not y squared, I started writing while I was talking. Stick our y in there. Okay, on both of those. Okay, so now I've got 4x times 4x is 16x squared. That's going to be a minus 20xy, another minus 20xy for the minus 40xy, and the positive 25y squared. Again, those are the same, so my answer on this one's going to be 4x minus 5y squared.